Well, good afternoon. I'm glad to see that you thought this was an interesting topic, but why should you listen to me? I'll give you just a little sketch. I got my first introduction to information security in the early 80s when someone threw an orange book at me and said, go secure all the systems you just installed. I said, what? What is that? Probably don't even know what an orange book is. You might. But it was somebody's idea of how to harden machines that could potentially be, I don't know, it was easy to do back then, but you could potentially dial in maybe and get somewhere. But the whole point was that it was daunting, and I had no idea that I would really be in that space, because almost 20 years later I said, well, I think I want to do that. And I guess right around 2005, 2007, somewhere in there, that's where I really started my information security career. By trade, by training, by education, I'm a software guy. I started off writing software on an IBM 36040, which is what they used to send men to the moon first time. So really dating myself, unfortunately. But I want to give back. I mean, I've got a good career, and I've always thought that necessity was always the mother of invention. And this is where black hole programming kind of comes from. I work in an environment where you don't have the internet. Oops, I'm a developer. Everything I need is on the internet. How am I going to get that unless I beg and go through 10 hoops with security and let them punch a hole to one thing that I might want? And then I realize, oh, that's not enough. I need 10 more things, and got to go through the whole process again over and over and over. Not going to happen. Nobody has that kind of patience. I certainly didn't. And there was that time when companies wanted to go to the cloud, and they had no idea what going to the cloud meant, except that it's going to be cheap. And let's do it. So I said, okay, and how can I leverage that? Because they opened up a hole to the cloud. And, I said, well, black hole programming. Black holes even emit things. I don't know if you've seen some of the pictures that come back from NASA lately, where they got big rings around them and all kinds of stuff radiating out. Well, that's kind of the network that we had. I guess I need to move on here. I've introduced myself, and I've almost got into the talk. Hopefully it works. There we go. All right. So, does anybody know what a black hole network is? Anybody ever heard of it before? Well, it does have a definition. And we'll go into that. To get around being in one of those kinds of networks, you really got to think out of the box, and in many ways, think like a hacker. Got to get creative. And you leverage the cloud in my case. There might be another way to do this, but in my case, I chose to leverage the cloud. So, what's a black hole network? It's typically something that just drops incoming traffic if it doesn't like it. No send back, no acknowledgement, no handshake, just boop, it's gone. Silently dropped. Typically, a network like this has multiple layers to it. It's got lots of defenses and all kinds of stuff. And to get anything done, you have to be very explicit about what it is you want to do. And if you go through all the hoops, all the things that the security folks want, both physically and cybersecurity wise, which, I'm a cybersecurity guy, so I kind of understand why they're asking me to do these things. Anyway, a lot of times when you ask for something, these big sites like GitHub and others have multiple IP addresses, and they span the globe. Well, no network firewall administrator is going to allow you to access all of those. They're going to say, okay, agree on a set, and we'll go with that. Well, that's fine until it doesn't work. So anyway, got to get creative, like I said. This is typically a homogeneous black hole network. Not telling you anything. These are just icons I picked out that kind of demonstrate the layered defense that you might typically see on a network like this. Of course, you've got your outer defense, your brick walls and fences and, turnstiles and all that happy stuff. And then there's firewalls and intrusion detection and virus detection and so forth and so on. And you got administrative controls, and it's just layered with all kinds of things that make it difficult to get out, except when you're supposed to, or come in for that matter, because things are being dropped whether you want them to or not. As a developer, a black hole network is really hard to work with. Everything that we need as a developer in today's development environment is on the internet somewhere. If you want a library, or an application that solves a problem that you don't have to write, and again, it's the industry driving it. You are really being held to a high standard for getting things done quickly and not causing costs to go through the roof. Excuse me. Many ways, as a developer, you got to think like a hacker. You got to know, well, what is my network like? How do I leverage what's there to get what I need out of it so that I can do builds and produce products that are useful inside this network? You always have budgetary constraints and everything is in the way. So this seems like it's impossible. This is the typical process for a continuous build development. With security scans and all that happy stuff. And if you're on an internet connected host, this is pretty simple. You can do this all day long. But when you're not, you got to split it up. You have to pick out the things that got to have internet access and the things that don't. And the things that don't stay on-prem, and the things that do go in the cloud. So you've got a split process, build process, that allows you to go out to the internet, get the libraries you need, they get scanned and all that stuff. And there's a certain amount of build that goes on so that it's packaged and ready to come on-prem to do the final build, checkout, and all the other things that need to be done before they become a product that goes to production. So we'll start with the cloud. These are the kind of things that you have to do. You got to build out your protected subnets, include gateway rules and restrict access to known IPs. You don't want just anybody to be able to log into your little cloud devices that you're going to put out there. You want to obviously know what all your edge router IPs are so that it'll allow them to go in and your home computer can't, or somebody else's home computer couldn't. And then you want to restrict protocols. In this case, it's just HTTP and HTTPS. And the only reason I included HTTPS was because I want to go that way eventually. Initially, in the cloud, unless you really do some homework and set up your, it's a money thing, really. Getting the certificates and everything set up so that it's a presence, and it's got a DNS entry and all that happy stuff. And the other thing too is that in your cloud, you don't want to allow your root user to have access. You want to set up what they call IAM logins and give it specific permission to the subnet that's going to be on that you're using, and then prohibit outside connections by default, except for the one that you want to use. And depending on how many addresses that is, it could be just one, or it might be half a dozen. Depends on how big a network presence your company or organization has. Did it go past something? Okay. Let me go back. No, I guess not. All right. I wasn't expecting that one. Okay, so to make it actionable, this is just a summary. We'll go into some details here. I guess it kind of got out of order in my mind. Divide up the process, build the on-premise surfaces, and then start operating. Okay, step one. Divide your build process up. Just simple rules. If something is going to require access to the internet, it's on your list. You build out your source code repository, your Docker instance if that's the case, your scanning software installed, and then a web server to host the artifacts that get produced as a result of this process. I didn't really explain this very well, but how I got the information or artifacts packaged was with a website. Initially, I'm using HTTP, and because I'm using HTTP, I also have a layer in there that encrypts the data before it gets posted to the website. So it's probably better than what you would do with HTTPS, because if you're a hacker, you can get the key, if you're watching the traffic good enough, and be able to decrypt it as it goes by. So in my case, I'm thinking like a hacker, so I don't want them to be able to see my code. So I encrypted all the data, then posted it, and then once it's gone through all its cycles that were in the cloud, and I have something to download, then I'm ready for the next step, which is the on-prem part. Of course, you have to build out the cloud services. Oh yeah, that's important. You have to set up your virtual private cloud, and I've redacted the actual IPs and things and names of an actual running VPC that I used to demonstrate this. And you build out all your outbound ACL rules and things like that. I subscribe to something called simplicity is the ultimate sophistication. And in my case, what I did was my inside network had full access. I didn't care because I was going to be blocking anybody's access to it except for the IPs that are mine. Of course, if we have an insider, we have that problem, but there's a lot of rules inside the network to prevent just anyone from going there. So I felt fairly secure that opening up the cloud to be able to go where it needs to go and not have be encumbered by any restrictions was a good way to ensure that anything that I throw at it in the future would be able to be collected, included in the build, and go forward. The key right here is in the gateway. The gateway is what really stops outside traffic from coming in to take advantage of it or exploit it or do anything with it. I'm only allowing 443 and port 80, and eventually I will convert it all over to 443, but I didn't because of the cost. I just didn't have a budget that would cover it, and all the extra fees that go along with a dedicated, instance and all that. This costs almost nothing to do. And of course, you build out your cloud services. I used open source whenever possible to stitch everything together. It's important to pick your poison, I guess. Some companies want to have, or organizations want you to have things that are supported. So that means there's a cost to it. Well, in my case, I don't have anything to spend on it, so I have to do it this way. So I'm using open source, spending the time to get it spun up, and building my pipelines and my Git repositories and that sort of thing. And then once all the services are installed, I'm just about ready to go. And how I seed the thing is with a text file that has all of the items that need to come from the web. In this case, they're almost all Python type libraries. I don't think I have anything else in there. But I've been known to do other things too, like pull packages, RPMs, and things like that that are important to the build that we're doing at that time. Now comes the fun part, building out your on-prem services. It's the other pieces and parts, but you got to have kind of the same thing. You have to have your code repositories, your Docker instances, your scanning facilities, and test and delivery facilities. Those are all on-prem. I don't know how you all feel about building into your build scanning of code, not so much from smell tests and things like that, but other things like are you using coding patterns that could be problematic under the right circumstance, that kind of thing. I try to build those things into my pipeline, but it's a changing environment, and as you learn something new, you go and build onto it. So that's the nice thing about a pipeline. You can just keep adding widgets to it till there are no more to add. Anyway, the on-premise needs those things to marry up with what it gets from the cloud. So here's the summary, and there's the build process we just talked about. We get a list of Docker images. They go into source control, and that kicks off the pipeline to go pull the images and then scan them. Various types of scanners. We clearly use things like Anchor engine and um, sonar, and there's another one we use too. They're all open source. I think I want to add a few more because from this conference I've learned a few things that I need to pay attention to. But the whole point is to try to build something that doesn't cause a injection of malware due to your supply chain, because you're making your supply chain a little more complicated, but in one aspect you're isolating and separating it. So it's kind of a trade-off there. And then, of course, the app admin, which is me, I get the results and review it and make sure there's no bad things that got ingested into the build, and there's nothing else I got to go back and fix. And then it's posted on the website. And down at the bottom on the on-prem, I'm the one that kicks off the initial job to start up the pipeline with the list of the same list practically that's over on the other side to pull all those artifacts to go into the build. And then we do our code scans again, because we don't know if we've introduced something new or somebody, caused some change en route. It could happen. Not likely, but it could. And then we in this case, I'm sending it to production, but it could just as easily go to a integration site, so that you can do all your beta testing and users test and all those kind of things that kind of guarantee that what you're delivering is what you expect, and the things that got fixed were fixed. Does anyone have any questions about any of this before I really covered a lot of material and skipped over a lot of details about how this worked. Like I really didn't talk about how the pipeline was built, because you could replace whatever it is I have with what you're using. It doesn't have to be open source. It can, if you've got the budget, go out and get the right tools and make it happen. Anyway, this went by a little faster than I thought it would, but
On your last slide, is the pipeline itself, I assume it's a self-built thing, is that kept in your source code control?
it is.
And so your source code though control is now out in the cloud. So
That part of it is. There's two parts to it.
okay.
There's the part that's in the cloud, it's separate and standalone, and there's the part that's on-prem, which is separate and standalone.
So how do you protect that one that is out in the cloud to make sure that it doesn't become a target?
Well, it can only be accessed by the VPC.
Okay.
It's not open to anybody outside the VPC. The only thing that's open to anyone outside the VPC from an outgoing standpoint is the web server. So if it gets posted to the web server, it can be reached by those IPs that are allowed. And I can see how you could potentially, get your gateway compromised. I mean, I don't trust anybody. So when I'm done with my job, the whole thing goes down. I don't leave it up. So it's not a constant process. I only start it up when I'm going to do a build. And then when it's done, everything is wiped and shut down. So it starts up new. Yes, sir.
Yeah, so you said you're the app admin, and you review the results of your initial code scan that runs in the cloud.
Right.
But then you review it again on premises.
That's right.
How often are you finding differences between the on-cloud scan and the on-prem scan?
Almost never. I have found some though, and it's not because of anything that was done en route. It was something that was not done in the scanner in the cloud. It was more details, I guess, when it got connected with everything else that it found it.
Did you immediately update the scanner on the cloud?
It wouldn't have mattered. It wouldn't have found it. It had to do with the ones that we find are relational. So by themselves, they're not a problem, but when they're combined with other things, they become a problem. Does that make sense? How they're used.
So you do like integration testing?
Right.
Okay.
Exactly.
You do SCA scanning for looking for transient dependencies for both vulnerabilities and licensing as well? Is that
I do. And one of the things we do in the build is when we do get a vulnerability, it stops. And we open a ticket with our vendor that, if we have one, depends on what it is. Some things just aren't. Sometimes you have to go to the author of the particular package that you're downloading or using and open a support case with them. And that part of the build is stopped until it's either resolved or we do our own homework and say, okay, well, we know that this function has got a problem with it. Do we use it? And if we don't use it, we might let it go.
Yeah.
Sometimes it's better just to leave dead dogs lie because they could fix something and break something else in the process. So something to think about. All choices that security types have to think about. You know, is the fix worth the risk? So, yeah, go back.
You never told us what kind of apps these are. Is that because I'm assuming this kind of convoluted protection means it's a government-related sensitive area?
It's not necessarily government related, but it's controlled manufacturing.
Okay.
It's on a export control list and all kinds of stuff.
Okay.
So, got to be very, very cautious about who can get to it and where it goes. I'm sure I don't know how much. I can't go into too much detail, but
That's
just
fine. I don't need to know more.
okay.
Where does your ticketing system live in this scenario? Do you have two that are synced, or one in the low trust, one in the high trust?
The ticketing system is actually on-prem, okay? And the part where something gets checked in up here at this thing, the source control, that's done in the cloud by me actually. I do that. I'll put it in I'll check it in, and then that starts a whole cascade of things happening with the pipeline.
I'm assuming everything in the cloud is ephemeral, right? Even your source control, you instantiate it as part of building, self-constructing and to spin up that environment when it's going to do it. That's why you tear it all down.
Right.
It's all ephemeral.
Right. That's how it starts. The pipelines like to have things in GitHub or your Git repository, and then that triggers a whole series of events that take place to go pull and scan and run your tests and all that happy stuff.
Can you elaborate a little more on that idea of ephemeral source control? So I'm familiar with ephemeral virtual machines to do code scanning, building, testing, integration testing,
Right.
we just mentioned. But I'm not sure I understand I'm not familiar with ephemeral source control.
Okay. How it's done is by a build script. The cloud gives you all kinds of extra things that you can do with it, and then a place to add your optional extras afterwards. And so the optional extras are what I put into the build to set up the environment. It's all code. It's all scripted. I mean, I have to wear my sombrero every now and then to go in there and fix it, but you know, it's I don't know if you're familiar with that term, but there are some places, not where I work, by the way, that don't want anyone to touch it, and if they do have to touch it, they have to put the pink sombrero on, and so everybody knows they're touching the code.
You are the ultimate insider threat in that scenario.
That's right, exactly.
So, for a developer that works along with you, and they're going to fix a bug or add a module or a feature, what repository are they pulling from? Where does that repository live, and does that?
It lives in flat files. In the cloud. There's it's just a, I don't know, they're just files that,
Like an S3 bucket?
yeah,
They
yeah.
pull down a file from an S3 bucket, they do their business, they check in this file, and that's what kicks off short control loop.
Does. Yep. There are other ways to do it besides S3 buckets, but that is what we're using at the moment. We got an image bucket that we put things in, and then there's also a log bucket that those logs go into. And I mean, I really wasn't trying to show you how to build it, but sorry, it's okay. I don't mind trying to help here. I mean, it was a learning process. I mean, it was not something that I just sat down one day and I'm going to go do this. I mean, this took me a long time to figure out how to do it. And some of you are a lot younger than I am and grasp things much quicker. And you may already know what some of those things do and don't have to learn them. So I didn't want to insult you with all the details. Anyway.
Well, I assume things like logs or maybe those flat files, anything that has any sense of permanence, whether it's artifacts of the build,
Right.
including logs, or content that's used in the build that you want to exist. I'm assuming there's some sort of synchronization process that lets you suck that stuff back through through your
There is. I can pull them back, and it's because in this firewall right here, they've given me permission to do HTTPS, all right, to the cloud addresses that they're using. They've got a contract with the cloud provider, and they didn't have this initially, but they do now. They have what they call an express route, and so I just hop on the express route, and I can pull all those things down, upload them if I need to, and we're good to go. In case you're wondering, we are using AWS, but I'm not trying to say that they're the be-all, do-all. I mean, all of them can do this. They just do it slightly different.
I guess so the gentleman pointed out that you are the ultimate insider threat, as your credentials are very much the insider threat. What is being done to protect the identity and access management between cloud, on-prem, and the other potential admins involved? Because there has to be a root admin.
There is, and it is maintained by our IAM staff. There is a separation of duties. I can't go out and create accounts. They do that. And depending on which cloud we're in, it may even be tied to the on-prem AD, which I never liked, but they do that. So I guess that's to make their apps work well.
We'll have to make spaghetti sometime.
That's right.
there you go.
Yeah.
Well, my whole premise was security apps. I'm a tool maker, so I'm building apps all the time that that need different things that are being developed by the cybersecurity researchers that are out there. And it's changing all the time. Platforms changing, we're very restrictive where we're at. Even our Linux type environments are arcane by comparison to something you would have at home. So it's fun. It keeps me up at night sometimes wondering whether it's going to work tomorrow.
That's one of the staggering things, because the more complexity, I understand why they built the layers, but the more complexity you have, we all know from clouds that that's, with configuration, the more complexity, the more likely there's a mistake. And complexity is really good at hiding mistakes that other people are good at finding and exploiting.
Right.
We all know most problems that happen on the cloud are configuration issues, right? Well-meaning people or ignorant people, either.
Right.
Just do things.
You could be in a hurry and forgot a step. It's easy to do. I've done it.
This is a theoretical question. I guess kind of random. What do you see, now that you mentioned that you've been at the conference, you've learned some things here, you may want to take back home, but what do you see as the next big improvement to your current process?
Stabilizing the environment, because every time I build this, I get a different URL, I get a different IP address, and I have to essentially program the on-prem to use that new environment. I mean, I've gotten better at it. It's now, I've got switches and arguments to it now that I didn't have before, but that gets old after a while. Every time you tear it down, you got to start over, essentially build your environment so it knows how to communicate with it. But it's gotten easier, but to really make it easy, I would like to stabilize it, and that costs a little bit. I've got to, pay for the certificates. I mean, I've created my own certificates, but our network firewall doesn't like them. So, so you got to get real certs. You have to get real IP addresses, which cost, and that kind of stuff.
Small money compared to probably what this stuff behind it is doing.
Probably, but you got to convince somebody to spend the money first.
I'm just what I'm used to.
No, I had a lot of fun with this. It didn't, like I said, it took weeks to get some of these blocks to work. And it's evolved over the last 3 years to what it is now. And I'm almost ready to go to the next level, which is to stabilize the connection. But I like the idea that it starts fresh each time. But having the same IP address, the same URL is a time saver.
But it changes the whole attack surface, right? If I don't know who you are or what you are every
That's true.
time,
That's
I'll
true.
attack you.
It is.
I can't create my attacker list. It's no good tomorrow or the next week, whatever.
Yeah, there's pluses and minuses there. I don't know. I could make it instead of a static IP, I could make it a make it change every time.
Oh, DHCP?
DHCP.
Okay.
But it would be a firewall thing too then. The only reason it's not a firewall thing now is because I'm using the express route and all the addresses that are part of it are in that block. So I don't know what I would get if I got a real IP address. It might be something that I would have to go through a lot of hoops to
But if you stick
get
to
that firewall to accept it.
if you stick to ephemeral, as long as you have a way of your express route sucking it in, JSON format or something, you can just again pull into a build on the inside that fixes everything for the new you.
Right.
Not you, but new
I hear you.
instantiation. I think you can get some automation with still preserving the.
Yeah, well, the whole idea was to automate this whole thing because it was an impossible thing to do manually. You know, we've got a tremendous investment in what we call SOAR, and I'm writing apps all the time for it, and that environment likes Python, and it likes Docker, and you add anything new to it, and you got to go build. So it's important to have that ability and that flexibility to make it happen. So does everyone here use Docker? No?
I'm not a developer, so.
No? You do? So that's the open source version of it. There's a, yeah.
We use both, the OpenShift and the open source version.
Well, that really is all I have. Unless there's no more questions, I'll give you your day back. I appreciate your all's attention. Thank you.